Okay, this video is for week number 7 to address task number 12, and I'm going to be completely honest. This was so challenging, and I'm really not sure if my explanation is good enough. I feel like I know what I'm doing, but I'm just so uneasy about this. I had a really hard time breaking it into steps A, B, C, D, and E, so I kind of just followed my own pattern. I know in the end result, we're trying to find the slope in the direction of when x is increasing by 2, y increases by 3, and it's dealing with the plane mx of 2 and my of -1. So the way that I began this problem was first by just addressing where the plane is. So I started with the value 0, 0, 0 because I feel like it's a fairly simple way to begin. So that would be at the origin of the XYZ plane. And from 0, 0, 0, if I am trying to find another point that would show the plane and the interaction with the directionals going on, then I would need to go ahead and find the rise in the x direction when x is changing. So the rise in the x direction is basically my change in z in my x direction. And the way that I need to calculate that is by taking my m of x and my change in x and multiplying those two values together. So when I take my m of x of 2 and my change of x in 2 and I multiply them together, I get a value of 4. The value of 4 is representing the change in z in my x direction. So that is going to give me my next point. So my first point was 0, 0, 0. If I'm changing in the x for 2, the z change that matches that x change is going to be 4. So my coordinate value is going to be 2, 0, 4. Okay, so 2, 0, 4 is actually going to be point B. So right now I'm showing you point A is at the origin, and then point B is going to be at 2, 0, 4. From there, I am looking to find how my z is affected with my change of y. So I'm going to go back to my original point of 0, 0, 0, and I'm going to apply my change of y and then my change in z in accordance to my change of y. So my change in y is 3, and the my is -1. So when I go to find my change in z in the y direction, I'm going to be multiplying -1 times 3, which will give me -3. So essentially what this means is that when I see a change in my y direction, I will see the change in my z direction to show -3 in z comparative to 3 in the y. So that gives me my third planar point, and that would be 0, 3, -3. And that is going to be point C, which is right down here. Okay, so between these 3 points, that is the plane that was formed. And that's where I began. And then I based everything else off of task number 7, to be honest, because I had a really hard time trying to figure out how to go about this. The first thing, though, that I did want to tackle was just my two-dimensional change in x and z, or I'm sorry, change in x and y. So that is this red triangle right here, right triangle, and that is going to show you that for every x change of 2, there is a y change of 3. And so I wanted to just get that taken care of. So basically from here on out, what I'm doing is my blue triangle is the triangle that is showing my change of x in accordance with my change of z in the x direction. And that is giving you the change of x, which is 2, and then the change of z in the x direction was 4. So that is forming the blue right triangle that we see here. And that hypotenuse on that blue right triangle is actually resting on the plane that was created using these directional slope instructions. So I feel as though I'm on a good roll, but I'm still a little mixed up about this. From there, I know that when I reached my point B, I'm then taking a turn and going from my point B to my change in y matching with my change in z in the y direction. So that would give me a whole nother right triangle. So basically what is happening from this new point B is I'm changing in my y 3 units. Okay, my change in y is 3 units, but yet the my is -1, which means that my change in z in accordance to that y change is going to actually be -3, which is what my right triangle shows here. The hypotenuse of that is lying between B and F, and that is showing me my my essentially, which would be -1. Going forward from there, the right triangle that we can form that shows the hypotenuse is resting on the plane and it takes into account the change in the x direction and the y direction and the whole entire kit and caboodle is this gray right triangle right here. And that is showing the directional slope of this plane. Okay, or so I think. I'm still feeling a little not so confident. This is a very honest video. Overall, how to put this together with slope. I feel very confident about the formula of slope, and I feel as though I have the right slope formula. I'm just nervous if my diagram is matching it. So when you're finding slope, you need to make sure that you're taking your rise in the z direction. So it's basically the change in z. Now the change in z breaks down to the change in z of the x and the change in z of the y, and you add those together as a sum. So in the previous breakdown, we found that the change of z in the x direction was 4 and the change of z in the y direction is -3. When you sum 4 with -3, you would get 1. So 1 is going to be our rise. We're going to need to hold on to that. From there, we need to find our run. And our run is going to give us the change in x direction squared plus the change in y direction squared, all square rooted. When you add those two values together, you square root it after that. And basically, you're just applying Pythagorean theorem in the two-space idea in order to get that run. So when we apply